Hello everyone and welcome back to the crash course. We're going to learn how to build the structures for project finance that generate circular references. This is the second video and we're going to learn today how to do the debt sculpting structure. If you would like to follow along with me, there's two options for you. One, which is completely free, and you can go to the website and download the start version of the Excel file that I'm using here and follow along during the series. Or you can go to the website and purchase the 4 Excel files completely done that I'm building up here. Let's gonna get started. As discussed, we're gonna do the debt sculpting today. And the first thing I wanna do, I wanna create a new sheet in here that I'm gonna use for this particular video. I'm gonna copy by clicking on Control. I'm gonna select the start sheet where I have the timeline. I'm gonna click Control. I'm gonna press on my left mouse button. I'm going to drag it to in here, which is cool. So I'm going to say debt sculpting. Cool. Now I'm going to also create this debt sculpting title in here. Sculpting title. I hope I got it right. And I'm going to just paste it in here. What is debt sculpting? Let's see through an example what that is. Let's say you have a project which has this cash flow in here. And for this particular cash flow, you went to the bank and the bank gave you a loan or a debt that we're going to be able to repay it into equal repayments of principal plus interest of $6.2 million. So let's going to graph it and see what the cash flows and the debt repayment looks like. So I'm going to go here. I'm going to select everything except for the number 0. We don't need it for now. We're going to graph it by pressing Ctrl F1 altogether. I'm going to just make it a bit bigger here so you can see what it looks like. And I'm going to change the type of the graph to be a line. So we're going to have a line here. That's it. So what do we have here? So the bars, as you can see here, they represent the cash flows. The first thing you should notice in here is how much variability this cash flow has during each one of the periods. I'm not saying if the periods represent 1 year or not. The thing is that there is a lot of variability. And for instance, in period 6, we have $5 million cash flow. And in period 8, we have almost $10 million cash flow. So there's a 100% difference between the higher and the lower cash flows for this particular project. So that's from the cash flow side. Now let's going to look on the debt repayment in here. So it's a fixed number. So we're going to repay as principal plus interest every single period the same amount, $6.2 million. And what you should notice in here is that for a few of the periods, as such in period 1, 4, 6, and 10, the cash flow of the project is not enough to serve the debt. And this can be an issue for project finance structures, because as in project finance, the strength of the cash flows should be able to repay for all the debts and all the suppliers and everything. So this is a concern for the bank because it's clear from this project in here, for these cash flows in here, that for a few periods, the project is not going to be able to serve it. And it's quite common for projects, particularly in the renewable energy sector, infrastructure projects, to have such cash flows because there's a lot of variability, either most likely because of seasonality. So let's think for a solar PV project, for instance, where this period number 6 here could be a winter time and period number 8 could be the summertime, or a hydro project where you have high and low hydrology seasons for a given river. So this is a real case scenario that banks are always aware of. And the fix to this when you're doing project finance is quite simple. So the banks are going to come up with what is called the debt service coverage ratio, or DSCR, debt service coverage ratio, which is a ratio. There's nothing more than this. It's a ratio. And this ratio is going to be a number. In this case here, we're going to say the number is going to be a 1.3. I'm going to copy and paste across here. So this is the ratio the banks are going to use to do what? To calculate the max that a project can take. So it's going to be a USD here. So this is going to be the max that we're going to be able to take. And how we're going to calculate it, we're going to get the cash flows and we're going to divide it by this ratio. And we're going to copy and paste across. Oops, we're going to copy and paste across. And we're going to just format it to become a 0. So instead of now being able to repay or $62.5 million, because of the debt service coverage ratio, we're going to be able to repay a little bit less. But what that entails to you, and we're going to change here to this line in here, this guarantees to the bank that in each one of the periods, the project is going to be able to serve the debt no matter what, because you're sizing your debt according to the cash flows that it has. So it's sculpting your debt according to the real cash flow of the project. And this is what that sculpting is. And we're doing the debt sculpting through or by using the debt service coverage ratio. So this is what we're going to learn today. How can we properly calculate this max debt, and how we can calculate the principal and the interest repayment, because that's what we're going to have here. The max debt here includes the principal plus interest. That's what we're going to learn. So that's going to go back. Let me just fix it here. It's going to go back now to our debt sculpting and see how we can do it. So we're going to start by having our cash flows. We're going to assume that we're going to have a cash flow of $700,000 for every single period. So I'm going to go here. Then it's going to be a $0. This is going to be our units column. And this is going to be in USD. That's cool. We're going to say that for each one of the operations period, we are going to have a $700,000 cash flow. So that's exactly what I just coded in here, as you can see per the formula here. I'm going to just format it now. It's going to be a $0. Nice. So this is our cash flow. So what we're going to have next? Next, we're going to have our debt service coverage ratio, or our DSCR. So that's what we're going to have here. It's going to be a ratio, and we're going to say it's going to be 1.3. The question is, how do banks assess this number? How do they come up with this number? And this number here is dependent of several factors. The main ones being who is the sponsors, or who are the sponsors, who is the off-taker, in which country the project is located, how long is the PPA or the long-term agreement for the off-take agreement for. So all these parameters come into the bank's assessment in order to determine which number this should be. We're going to say for now it's going to be a 1.3. I'm just going to have this number here, and I'm going to multiply by this one here. I'm going to press enter. We're going to copy and paste across, and we're going to format it to be $0 and a ratio. Cool. So that's what we're going to have here. So after this, we can calculate what our max debt. And as said before, and that's pretty important, this is going to be the principal plus interest that are going to be able to serve. It's going to be USD. And the only thing we have to do here is to divide this number here by this number. But we have to have an if condition here because of this diff 0 error we're getting here. So let's going to do this. Let's going to do the fix. So if what? If this is 1, then we're going to do it. Otherwise, it's going to be 0. I think that's correct. Just have to format. Cool. And what I want to do here, just want to copy. I'm going to go here to the sheet in here. I want to copy this one in here. I just want to paste in here. So I'm going to paste here, and I'm going to paste here. And I think that should be completely fine. That's good. What is the next step now? We have to calculate, and I misspelled again interest here, so let me just going to fix it. So we have to be able to calculate what's going to be the principal and what's going to be the interest of these cash flows in here, because we don't know, they're all mixed together. So we have to be able to distinguish between one and the other. How can we do it? And to do it, we can go to this other sheet that I have in here, where we have these cash flows in here. Let's see what we have here. Let's assume you have $2 million that you can borrow to your friend. So a friend of yours comes and said he needs or she needs $2 million, and you have the money. And I'm going to borrow to him or her. And I'm going to charge 10%. And the way it's going to work, you're going to be able to lend this money for 10 years. And you're going to charge 10% as interest rates, as we have in here. the way you're going to get repaid, so your friend's going to repay you only the interest or the 10% of the $2 million every single year. And in the last period, you're going to receive not only your interest, but of course your principal back. So that's how you're going to use. So these cash flows here, it is exactly as the cash flow as we have in here. It's the cash flow, exactly the same one. So 10 periods, you're gonna have this money back. Cool? So let's go back here. The question I would like to ask you, what is the NPV of this cash flow here? So I'm gonna get an NPV here. It's going to be USD. We're gonna say this as a unit. So the NPV here is going to be equal to the NPV. So the rate is going to be this one in here. And we're going to calculate the NPV. I'm going to grab this range in here. And I'm not going to use the period 0 because that's how you use the NPV. And if you don't understand why this is the case, I would really recommend you guys to watch the video that I did on NPV versus XNPV. What are the differences and similarities, and want to use one over the other. Now we have to stick with the NPV. We're going to add, and we're going to have to add this number in here. Cool. So this is the number. And I'm just going to format here. And as you can see, the number is $2 million. That's quite interesting, no? Because the $2 million in here, it is the same as the $2 million that we have here as our initial principal, as initial money that we lent to our friend, correct? And this is exactly what it is. Whenever you NPV your cash flows using, and that's very important for this particular case here, using a constant rate, the NPV of that number, it would be the same as the principal of the debt. So that's it. But pay attention again. We have to have constant interest rates here to make these calculations valid in Excel. Otherwise, the way you're going to use the NPV and XNPV, that's not going to work. So in Excel, for this to be valid, we need to have this number here, constant. Cool. So let's going to go back now to our debt sculpting and calculate it. So what we're going to have here, we're going to have our interest. We're going to say it's going to be a percent, and this is going to be a 5%. So that's what we're going to have, and let me format in here, percent. Let's calculate now then our NPV, which is our principal. So this is going to be our principal, going to be in USD. I can also go here and again the unit. That's good. Nice. So what's going to be our NPV? And in this case, I'm going to use the XNPV. So it's going to be equals to the XNPV. Oops, sorry. It's going to be equals to the XNPV. So we have it here. So this is going to be our rate. The values, we're going to grab our values in here because this is the max stats. This is the cash flow that we have to NPV as we discussed before. And these are the dates that we're going to use, correct? I'm going to press enter here. We're going to format. I'm just going to format again and comma 0. And there we go. So our NPV for this cash flow here, discount at 5% interest rate, it's going to give us the $4.8 million. The question is this the right NPV? Are we properly calculating the NPV? Let's going to see again. So we're calculating, so our NPV, our cash flows to the 31st of March. So this is what the NPV is doing. But this is not really what we want. What we need to know here is what is the NPV at the 31st of December, because that's when we're going to receive the debt from the construction phase. And that's the total amount of the debt that we have to repay. So we have to compare everything to that particular date. What we're going to do, we're going to recalculate our NPV to this date exactly in here. I'm going to press enter. And this is the NPV that we're going to be looking at. So we're going to be able to, or by the end of the construction phase, to have a total debt as a principal debt amount of $5.038 million. So this is the total principal that we're going to be able to get it. This is nice. So we have our principal here. And if you have our principal, we can start building up our debt account and see how much we're going to be able to, how much money we're going to be able to draw down, the total debt, which is going to be the 5 million. In our IDC case here, the total number was $4.6 million, as we have in here. In this case here, it's going to be just a bit more. So we're going to be able to draw down a bit more from our debt. So let's going to start building this. So we're going to have here our debt account. I'm just going to do a Control U here so we can just highlight this is a debt account. Maybe we can just skip one row here. So let's see now. So we're going to have our open balance. So that's always what we have in our debt account. We're going to have our drawdowns exactly the same way we had in our IDC calculation. We're going to have our principal repayments, and this is the new because now we have to repay our principal, and then we're going to have the closed balance. This is how it's going to work. Everything's going to be in USD here. I'm just going to copy and paste across here, and that's what we're going to have. So we're going to copy also these structures here, so that's good. And I also copy this one here and here. Cool. Let's see the follow. So what are we going to have here? So the open balance is going to be equal to the closing balance of the previous period. So we know this already. I just want to set up here as a technical input. So we know there's nothing in here, but the cell is being used. So what's going to be our drawdowns? So our drawdown, in this case here, is going to be the date when we're going to transfer the debt from the construction phase to the operations phase. So this is going to be at construction. Sorry, it's going to be at construction end. So that's when we're going to do. So if you recall, we have during the construction phase, we're going to have our IDC. And at the end of the construction phase on 31st of December, we're going to have to transfer whatever amount of debt we had incurred to our operations phase to be repaid. So this is going to be transferred at the end of the construction phase. So what we're going to say here, we're going to say if what? If this date here, I'm going to press F4 twice, is equals to this date in here, I'm going to press F4, then we're going to have this number here, F4, otherwise it's going to be 0. Right? So we're going to copy and paste this across. And as you can see here, we're going to have this amount of money transferred to this account here once we enter or finish the construction phase. So there's just one mistake in here. So this is the principal payment here. So that's why this should be principal payment. Cool. So we're going to have to leave this blank for now. We're going to calculate it later because in order to understand how much principal we're going to be able to pay, we have to first calculate our interest, which we're going to do in a while. But the closed balance, as always, is going to be equal to everything that is above. It's going to be equals here. So we're going to copy and paste everything across. And I'm going to set this with a top border by pressing Alt H, B, and then P. There we go. So that's what we have in here. And this should be correct. Now that I have built this structure in here, we can calculate our interest payment and our principal payment. That's the two variables that are still missing. Payment. This is going to be a USD. That's fine. So let's going to calculate our interest payment. So what's going to be our interest payment? Let me just copy the structure in here. So what's going to be our interest payment? So let me delete. The interest payment is going to be equal to the open balance of our debt multiplied by the interest rate, which is this number here. Oops, sorry. This should be this one here. Times the interest rate here. Correct? Let me just anchor this thing here so we can see what we're going to have. So is this correct? No, because we can only, the difference between the principal and the max debt is $300,000 approximately, but we're paying $2.5 million, right? So we have the principal, this is the max principal plus interest, and the difference between the principal and this number here should give us the interest, which is $300,000 given or taken. So let's going to calculate here. So actually it should be this number here or this number here minus this number here. So this is the maximum interest we can pay, but we're getting here $2.5 million. So what is wrong here? What's wrong is the interest rate that we're using. We're using the 5% per year. So we have to calculate our interest rate for the period that we are taking this repayment for. So let's gonna do it. I'm gonna say the following. So what I'm gonna do, I'm gonna grab this interest here and we're gonna paste it in here. And we're gonna say it's gonna be this number here times this one here. So we're gonna copy this number here. So this is gonna be our percent. I'm gonna add an extra row in here. That's going to be our interest too. But instead of having percent per annual, we're going to have a percent per period. That's exactly what we have in here. So we're going to calculate how much of this 5% in a given year is going to be for an interest for this particular period here of 3 months. And I'm going to do it not the same way as we did here for the interest during construction, where we only divide the interest per year by the number of months we have. We're going to calculate the effective interest rate. I'm going to be a bit more precise in here, just because of the NPV calculations in here. So I have to be a bit more precise. How are we going to do it? We're going to say it's going to be equals to what? It's going to be equals to, open parentheses, 1 plus this number here, close parentheses, to the power of what? I'm going to open 2 parentheses here, and you're going to see why. The first one, I have to calculate the difference of the number of days between this and the previous date. And then I'm going to have to divide this number here by the number of days in a year. So that's what we have to do here. And I think that's it. Yeah, so we're going to have now to do -1. And that's what we have here. So it's going to be 1.21%. And also, let me see here. So that should be, yeah, so that's going to be it. So what I did in here, let's going to see. So we're compounding this interest rate here, the 5%, by what? By the difference between the number of days between this period and the previous period. And I've divided it by 365. So I'm just compound it by the number of days that we have in the period and divide by the number of days in the year. That's exactly what I'm doing. So if you press F9 here, so we have 90 days between this period here and the previous one. And I divide the 90 by the 365, of course. That's this 365 we have here. Let me press escape so we don't mess up with the formula. And now I can just copy and paste everything across. So now we have exactly the rates for each one of the periods that are gonna be able to calculate our debts, or not our debt, but our interest. So I'm gonna delete this one here, and we're gonna multiply by this one here. So I'm gonna copy and paste, and there we go. So we have the $6,000 in here. This number is not correct yet. And because, as we said before, the difference between this number here, which is the max debt, and our principal should give us the interest, and that should be $345,000. So I'm going to leave this one here for now, just for reference, but we have $6,000 in here. Why is that? So the reason why this is wrong is because we have to reduce our principal payment here. So let's go and calculate the principal, and then everything should work finally. So what is our principal? Our principal payment is the difference between the max debt and the interest right here. That's going to be our principal. We have 4 million right now as principal, but we can have up to 5 million. But what we have to do now, we have to grab or to say that this number here is equals to this number here. So we're going to say here, we're going to copy and paste, and there we go. But we have to multiply by -1. So let me redo it. So it's going to be equals to this number here multiplied by -1, because it should be a negative. There we go. Everything is correct now. So let's see if everything makes sense in here. So what do we have in here? We are getting the 5 million that we calculated in here, and we start repaying as a principal during the operations phase. And by the end of our debt tenor, we have 0 close balance. We have finished, we have paid all our debts in here. And the total amount that we have paid is the $5.38 million, which is exactly the same number in here. And the total interest we calculated, it is the same numbers in here, $345,000. So everything looks good in here, and we have our debt sculpting, correct? What do you think? It is correct, but not so much. Why? Because if you recall, this is a crash course on infrastructure that generate circular references. But for now, there is no circular reference. As you can see here, we were able to model everything correctly, but there is no circular reference. So what is wrong? What is wrong here is that we started from the wrong point. And I misguided you when we set up this cash flow in here. So I just said it's a cash flow, but I didn't really mention what sort of cash flow this is and how you calculated it. And this is the reason why we did not get a circular reference for now. So what is the problem here? So the problem is with this cash flow, as I said earlier. So what is this cash flow here? So this cash flow here should be the cash flow available Sorry, let me just available for that service. So let me just rewrite everything. So it should be the cash flow available for that service. And how do you calculate it? So that's very important. So what you're using here was really the cash flow available for that service. And sometimes you can see people using some sort of cash flows, which can be most likely the EBITDA. So if you see that sculpt that does not have any sort of circular reference, most likely what the people are using, the person is using that's modeling that particular that sculpting is the EBITDA. But this is not correct, or this is a simplification so that we can avoid the circular reference the same way we did for the IDC. But in this case here, I would say it could be off by a lot, your calculation, because you not account for lots of things in here. So I would not recommend you to calculate your debt sculpting using the EBITDA. What I would recommend you to calculate your debt sculpt on is based on the cash flow available for that service. And whenever you're using that, you're going to have a circular reference. So let's see what the CFADS, or the cash flow available for that service, is. And we're going to see in here. So what is the CFADS? The CFADS is calculated based on your EBITDA, so which is the interest, so the earnings before interest, tax, depreciation, amortization, minus your capital expenditures, which is whatever capex you have to come up with during the operation phase. Then you have to adjust it for your working capital. And then you have to reduce your tax payable. And remember, tax payable is a function of the depreciation and the interest expense that you have in your project. And that's going to generate your CFADS. So when you have your EBITDA minus capital expenditure, minus plus minus working capital adjustments, minus your tax payable, you're going to have your CFADS. And what is your CFADS? What is your cash flow available for debt service? It's going to give you the max debt, which is the sum of your principal and interest expense. So the CFADS, then we're going to use here the DSCR. The DSCR, we're going to calculate using the DSCR or max debt, and our max debt is the principal plus interest expense. But remember, the interest expense is going to be going back here to your taxable payable. So the more interest expense you have, the lower is going to be your tax payable. And as you can see here, the circular reference is going to come up here, because the lower your tax payable, the higher your CFADS. And there's a loop in here, and that's where the circular reference is going to come from. It's going to come from the interest expense that is an input to the CFADS calculation and an output to the CFADS calculation. So that's where the circular reference is. That's going to go back here to your debt sculpting, and we're going to do it in the very proper way. So we're going to call it the cash flow available for that service. Or let me put here the CFADS, because this is quite a common way to call it. I'm going to add a few rows in here, and we're going to start modeling our cash flow available for that service. So what are we going to have here? So what we're going to have, I'm going to grab this, I'm going to copy this over here. I'm going to call this our EBITDA. So our EBITDA is going to be the $700,000 now. What I have to do, I have just to multiply this by this number here. So this is going to be our EBITDA now, the $700,000. What we're going to have then, we're going to have our depreciation and amortization. So it's going to be in USD. And for the sake of the exercise, we're going to say this is going to be 0. This is going to be 0. It doesn't really matter for now, but of course, in a real project, we are going to have some numbers in here. So that doesn't really matter for us now. So this is the second component of our calculations for the CFADS. So we have the EBITDA, we have the depreciation amortization. We're going to also assume, for the sake of the exercise, that the capital expenditures and the working capital adjustment is going to be 0. So I'm going to just come over here. So we're going to have the capital expenditures and the working capital adjustments will also be 0. So that's what another assumption we're going to have. So I'm just going to copy here. I'm going to have here, and then I'm going to copy and paste everything across. So we have all these things here going to be 0. But what's not going to be 0? What is not going to be 0 is the interest expense. So we have to come up with the interest expense, so then we can calculate our tax payable here. So this is not going to be 0 because this is where the circular reference comes from, and because we have that, we do pay interest expense. So let's going to go back now here, and we're going to calculate our interest expense in here. I'm going to add a couple of more rows in here. So we have it. Then before we get that number in there, we're going to have our earnings before tax. So what are we going to have here? So we're going to have here, we're going to have here, and we're going to have here. I just want to copy the structure here. So what's going to be our earnings before tax? It's going to be equals to the sum of these numbers here, comma, our interest expense, which we're going to calculate later. So this needs to be calculated. Let me just leave here like this for now, because we have to come up with these numbers here later. I don't want to put these numbers here now, but we're going to do it later. That's going to be our EBIT, or earnings before tax. Let me add a few more rows in here. Then we're going to have what? We're going to have our payable tax. And then we have to come up with a tax rate. Let's say it's going to be a USD. We're going to have a 20% tax rate. Going to be a tax rate here. This is going to be table. We're going to have a percent. So it's going to be a percent and an in-sheet formula here. Cool. So what's going to be our payable tax? It's going to be equals to this number here times our tax rate. So that's going to be our payable tax, but we have to multiply by -1 because this is a cash outflow from the project and want to see this as a negative number. So out of the 7 million of EBIT that we have for now, 20% of 1.5 million is going to be paid as tax. So this is what we have for now. Then we're going to have our capital adjustment and working capital, which is 0. And then finally, we're going to have our CFADS, because now we have everything to have our CFADS. So we have the EBITDA, we have the depreciation amortization, we have the interest expense, we have our tax payable, and then we have these capital expenditures and the working capital adjustments. So that's everything we have for now. We can then calculate it. So what's going this to be like? It's going to be equals to EBITDA, or actually it's going to be equals to our EBIT, earnings before tax, plus our payable tax, plus our capital adjustments, plus this number here. So this is going to be, I can get rid of this. This is going to be our cash flow available for that service. So we no longer have the 7 million now. We only have now the 5.6 million, correct? But of course, now we have to add our interest expense in here, because that's where the circular reference is coming from. And as soon as we make this number here equals to this one here, and multiply by -1, because this is payment, so we're going to reduce, our payable tax with the interest expense. So this should be a negative number. And you paste this across. We have the circular reference comes up in here, as you can see in this calculation in here. So that's where the circular reference comes from. And this is why people get a bit lost with that sculpting, because it's a bigger calculation, then you don't really know where the circular reference comes from. It's a bit more difficult to understand where the circular references come from. So how do we fix it now? Let's learn how to fix a circular reference. So we have to always break up the circular reference or the circularity somewhere. And I'm going to break up in this point in here. So we're going to break this point in here. That's where we go. Of course, there's nothing here to be added as a that to your projects. What do we have to do now? The way I'm going to do this for now, I'm going to say that these two numbers here, they need to be equals. They have to have different signs. In the absolute values of these two numbers here, they should be equals. What I'm going to say that this plus this, and I want this number here to be 0 by changing this number here, because remember, there is still a connection between this cell here. So as long as I put some numbers in here, we're going to have numbers in here. So what I want to do, and if I keep increasing the numbers here, let's going to add it, multiply by 10. You can see the number here keeps changing. So what we need to do now, we need to do a go seek function in Excel by pressing Alt A W G. So I want this number here, which is already selected here, to go to value 0. by changing what? Which cell? By changing this cell here. And we're going to press OK. And there we go. So now we get the $3.8 million as the total principal for this project, and everything matches. So we have a zero closing balance at the end of the tenor, and the total principal is equal to the total principal here, so the numbers are the same. And we have, when you add those two things together here, let me add these things together here, to give $4.1 million, which is exactly the same number as we have in here, as our max step. So everything matches and everything makes sense in here. So that's how you're going to be able to calculate that sculpting, by calculating the difference between the drawdown and the principal and setting this number to 0 with a goal-seek function. Last thing here I want to do is just to calculate exactly whether we did achieve the 1.3 DSCR, because we're given this cash flow here and you calculate this max stat in here. So let's see if in fact we did achieve the 1.3 DSCR for this calculation in here. So how can we do it? We can say that this number here is going to be equal to this one here divided by the sum of these two numbers in here. We're going to be given error, but overall we should be able to get the 1.3 that we're looking for here. So let's change now this number here for 1.5. 1.5. So now we don't have it correctly now. So there's a difference here, so we don't get to 0. So let's gonna set up this number to go to 0 by pressing Alt AWG. So we have the reference already to the correct cell. We're gonna press Tab and gonna make it go to value 0 by changing what? By changing this number in here. And there we go. So we did get to 0. Everything is 1.5 in here, so everything's correct. So we have the 3.75 here, the 3.75 here. And if we add these two numbers together in here, we're going to have the 3.6 million, which is exactly the same number in here. Cool. I want to do one more thing with you guys and see whether that's going to work or not. So I'm going to copy these numbers here. I'm going to paste it as values. And I want to, as an input, so we no longer need this one in here. And now I'm going to change. I'm going to have half of the periods in here. We're going to have 5%, and the other half we're going to have, let's say, 10%. Let's see if it's going to work for us now. So we have a rate, an interest rate that is no longer constant in here. And remember I said that whenever we calculate the NPV, we should have the constant rates in here. But now, if you notice, we're not calculating the NPV anymore. So that's the difference. That's why it's important to understand what you're doing here. I was going to make this number go to 0 now. So we're going to say Alt AWG. We're going to change this to go to 0 by changing to this cell here. I'm going to press OK. Let's see where to go. As you can see here, we did achieve everything correctly, even though we have a different interest rates in here. And the only reason why we're able to do so is because we're no longer we're no longer calculating the principal as the NPV of these cash flows in here. That's the only reason why, because if we're to calculate the NPV, I'm going to do it right now in here. So X NPV. So the rate is, where's the rate? The rate is the 5%. We don't have even the rate now because the rate changes over time. So we can't even calculate it. Another way we can do it though is by manually calculating it. Let me do it. How do we do it? So the NPV, it's going to be equals to what? It's going to be equals to this number here divided by what? 1 plus this number here. So that's the rate that we're looking for the period, to the power of what? I think I have to open a comma. Fill up this one is in here. So it's going to be equals to the difference between this date in here and this date in here. But I have to fix it because for every period, I always have to compare with this date here because that's when we are NPVing our cash flows against, divided by days in the years. And I think that should be it. And that's the NPV we have. Let me just see if the calculation is correct. I just want to copy and paste everything across. Yeah, so we're always calculating the NPV against this period in here. But I grabbed the wrong rate because we have to grab this rate here because we already normalized this for the yearly rate. So now we go and we have it. Let me just grab this thing in here and copy in here. And as you can see, the numbers don't match. So this number here is different from this one in here. Why? Because we have a different interest rate. But if you copy and paste everything across here, and then we calculate again our goSeek function by pressing Alt AWG. I want this number to go to 0 by changing this number here. Then, as you can see here, the numbers match. So again, just pay attention. Whenever you calculate your debt sculpting through the NPV function, just make sure or it will only work as long as the rates are always the same. That's it for today, folks. So today we learned how to do the debt sculpting. And the main takeaways from here is that you need to understand where you're getting your debt sculpting from, because you need to get your debt sculpting from the cash flow available for debt service or CFADS. That's the correct way to do. But whenever you do it, a circular reference is going to come up. It's going to show up in your model. The reason being, it is because in the CFADS, the interest expense, it is an input and an output of the calculation. And that's where the circular reference is. It is also possible to see in a few modelings, in a few financial models, that people calculate your debt sculpting based on EBITDA. And I think even in one of the exercises that I did in the past, I always calculate it based on the EBITDA. But that's not 100% correct. I'm not even sure if banks are going to accept it, because there's a big difference between the total cash flows from EBITDA and the total cash flows after for your CFADS, because you have to account for tax payment in here. So in the next video, we're going to learn how to model the debt service reserve account. That's going to be the third video of the series, and that we're going to have to bring everything together, because the debt service reserve account is a number that we have to account for during the construction phase, but we have to model it during the operations phase. It's going to be a pretty interesting one, and I hope to see you in the next one. Bye.